Hi, my name is Dylan Barks, and I am a senior at Weber State University, and I just wanted to make a quick video about a topic that most of you will probably come across in your data structures and algorithms class called a linked list. When I first encountered this, it was a very confusing topic to me, and kind of the first thing that made me really think about memory and how that's used in the programs that we write or in your computer. And so I kind of just wanted to take some time to explain it in maybe a way that I wish that it was explained to me when I first learned, or just in maybe a different way. So I just thought I'd go through that here to maybe help some of you guys out. So what I wanted to start with here is let's talk about memory. So most of the time when we're storing things in memory, I think we usually default thinking about an array. So with an array, so we have this block of memory here. An array needs to be one contiguous block of memory. So we allocate, say, this, and we store things like this, and it all has to be in this continuous chunk here. So we would have our indexes and so forth. Whereas a linked list is interesting because these bits of memory, or our linked lists, do not need to be a continuous block of memory. They can actually be anywhere, and that's kind of the beauty of it, is that we store a link to each one. So it's definitely more efficient in its memory storage. It does have some pluses and minuses, so inserting and deleting is actually quite quick for a linked list. That is actually going to be constant time, if you're familiar with time complexity. But unfortunately, with searching through a list, because you do have to go through each link, that is going to be linear time, whereas we really just have these, we can use indexing with arrays, so it's a lot easier to access, say, something at your fourth index. So that's a little bit about linked lists, but let's get into exactly, or some base knowledge, I guess, going forth with them. So what is a linked list made of? So every piece of memory, or every memory address, we are going to store what we're going to call a node. So here's our node. And a node is going to be made up of two things. It's data, and this thing we're going to call next. So data is going to be here. We're going to be storing some strings, so we're going to store maybe my name first. And then we're going to have this next. So this next is actually going to be our pointer to the node that follows. So this next is going to link to the data here. And then we would have the same structure. So that's kind of the idea. So let's get into some of the coding here. So how do we make this node? Well, like I said, we need a string data, and then we need a node called next. So like I said, this node is kind of how we keep track, and this is the linking that is talked about with a linked list. So in our constructor here, this data is data. Now, so when we instantiate a new node, we're going to set that to null originally. So we're going to have to make sure that we configure our .next when we are creating our linked list. So I do have this space over here that we can kind of build this linked list as we go. So hopefully, this is what I was kind of wish that I had when I was a student is kind of a side-by-side play of kind of how this is constructed. So our linked list, I guess two important aspects to think about. So look, we've already constructed this here. So we're going to have two properties, and these are going to be our head and our tail. So, and we'll get into more exactly what that is, and obviously these are going to be, this is a node and this is a node, so we're going to have a node head and a node tail. Cool. So these will be moved around so we can keep track of where the start of the list and the end of the list is, because that's all we really need. So if there's elements in the middle, we know we can start from the head or the tail, and we can kind of traverse this linked list. And do keep in mind, yeah, it's just kind of cool because these are pointers to these spots in memory that don't necessarily need to be next to each other. They could be on completely opposite ends of, the heap or whatever memory we're working in. So let's get in, and we're gonna code this method called insert at head. So inserting at head, what is this gonna look like? Well, we got nothing in our linked list right now, so we are going to insert a node here. So how do we do this? Well, our method takes in data, obviously. So we're going to make this new node here. So we're instantiating a new node. We're going to give it some data. And we haven't really set a next, so that's just going to be null for now. So what do we have to say next? Well, we want to insert at the beginning of our list. So if we had another node, we want to make sure that our next points to that node. So obviously we don't have anything here right now, but we need to make sure we point to whatever is currently the head. So we don't ever break our linked list. So the important piece here is our new node dot next is going to equal our head. So that way our linked list is intact. And then we're going to set our head to our new node. So see how that works there. So yeah, essentially this is the new head of our list, so we need to, we need to go ahead and always assign it. So basically we're pointing to the old head first, and then we're going to set the new head to our new node. So that should work as so. Now we have to do some checks here. So if we don't have a tail yet, say we've just inserted this first node, so if our tail is still null, our tail is going to equal head. So this is the situation that we have here. So our tail is currently null because we haven't done anything with it. So our head and our tail is like so. And when we add a new node, so let's say if we inserted at head, so let's run through this code again. So if we insert, let me just see if I can move this around. So this is our method here. We've completed insert at head. So if we're going to go ahead and insert a new node here, so we're going to make our new node like so, Cool. New node not next equals head. So where's the head? It's over there. So choop. We're doing that. And then we're going to say head is our new node. So we need to move that over there. And then we're going to do a check. So if tail equals null, which nope, it's not. So now this is our tail. And we're good to go. One thing to note too, so this node here, we've never set a next for that. So that's going to be sitting as null. So that's how you can kind of know where the end of the list is. So let's try our next method here. So insert at tail. So we're pretty much gonna start the same way. And instantiate a new node there. But this time, what we're going to do is we need to make sure first that we need to check if there is no head. So in our scenario here, we do have a head, but we just need to go ahead and say that if our head equals null this time, then our head needs to equal our new node, and our tail is also going to equal our new node. And then we would return. So that's if we're inserting at tail and nothing is in there. So in our scenario, we're actually going to, this null is going to be passed over. And so what do we have to say here? So we want to insert something at the tail. So here's our new node. Let's fill out our next. So we need to say that our current tail dot next down here, we're going to point to our new node. So we're going to point to that spot in memory. And then we're going to just simply say, well, this needs to be our tail. So tail dot next equals new node. And our tail equals our new node. So there we go. And that will be our insert at tail method. So you could follow the same steps here. It's yeah, very important, I think, to remember that we can't lose the pointer here. So when inserting at tail again, we create our new node, and then we got to say, well, shoot, our current tail, we need that to point to our new node. So our list is intact. And then we need to make sure, so this will still add, but the key point is we need to keep track of that tail. So honestly, a pretty cool concept, and I think once you get the hang of it, it starts to be pretty fun. I'm just going to cover these two methods, but you could think about how a method could be constructed to maybe insert between these, you know, say insert after our second element here, how that might work. So I would challenge you to maybe write that method using what you know about linked lists so far. And I'm going to go ahead and just run some tests down here. So I've already written these, so I would instantiate my linked list, which is what we've been creating. So I'm going to get a new linked list. You're going to call it LL, and I'm going to insert at our head Bob. And then I'm also going to insert at Sally. So we would expect this to be Sally, and this to be Bob. And I've also added some, it's going to end up saying null at the end to let us know that we've reached the end. So let's save. we're just gonna come in here. It's accidentally running over here. So you do see that we have Sally and we have Bob, and then we have null. So what happens if we then insert Dylan? So let's run this code over here. So insert ahead, Dylan, Sally, Bob. So we have that working right. So now we're going to insert at tail and see what this looks like. So we would expect this null to be replaced with Lola. Which it doesn't seem like it is. That seems a little strange, probably because we didn't save the file. Like that. So we've inserted at the tail. So now our tail of Lola is now pointing to null. So if we come back and visualize that, you can see that here this is going to be a node that, well, this dot next was null. So I hope that this has kind of helped to visualize this a little bit. I think it's a really cool way to start thinking about memory and pointers. Because like I said, that was something that when I heard that floated around, it seemed a bit intimidating, and I think just really understanding linked lists kind of helped me not be so afraid of pointers and memory and what all that is, and I think it'll lead you to be a more efficient programmer and just hopefully enjoy the craft a bit more. So yeah, thanks for watching. Leave a comment if you learned something. Cheers.